ship is going to take a picture. While he's doing that, I've been asked to tell about my background. I got into this. Oops. When I was in college, I actually was a chemistry major, and one day came up. So, anyways, I was came home from work, and we only in the canyon in Sierra Madre, California. There was very limited parking, and so this is the skunk story. So there was this big van sitting in my parking space, and I had to park way down in the parking lot and hike up about 100 stairs to get to my house. The van was there the next day, and I saw the guy get out, and he had a big knife, tattoos everywhere, scars, really rough-looking guy, and he goes, I says, "You can't park here. This is my assigned space. You'll have to park down the hill." He said, "Make me." So I thought about that, and I said, "Oh, okay." I went off to work, and I saw a neighbor, and I said about this guy. He says, "Oh, don't. I wouldn't mess with him. He's almost killed a few people. I would just leave him stay at your parking space and go down the hill and park. It's the safest thing to do." Now, I worked at Avery Label on the sticky side of it. We were doing the glue research, and I was an analytical chemist. We had all kinds of nasty, smelly chemicals. But one of them is called beta mercaptoethanol. And it smells, one drop of it smells like 10,000 skunks. I go, huh. So 3 in the morning, he kept the window down on his van for some air, and him and his girlfriend were sleeping in the back of his van. I injected 1 million skunks into his van. And I ran up to my apartment, and the van started rocking. The door flew open. They jumped out. She was banging him over the head with a pillow saying, "I told you we shouldn't live up here in the mountains. There's a skunk in here." And they left, and I never saw them again. And I call that better living through chemistry. Uh-oh. So then I got into electrical engineering. I've been a ham radio operator for well over 50 years. When I was 16, I got my ham license 2 days after they landed on the moon in 1969. So been a ham for a long time, and I got into high altitude ballooning. There was no one else doing it except the Weather Service in 1987 on August 15th. Why August 15th? It was my birthday. So I figured it was the biggest birthday balloon possible. So anyways, some people have noticed over the years, I've attended 20 GPSLs out of the 24 that have occurred. I started on GPSL 2, and I've only missed a couple in between. But people have always commented, "Bill, you're always wearing a NASA cap at the GPSL." I said, the reason for that is I'm hoping that eventually it will, through osmosis, I will eventually get to work at NASA. Well, 5 years ago, I was called in for an interview at NASA. And they asked me, "Now, Bill, you're at retirement age. We would really like you to be here for 5 years if we give you this job." And I said, "My goal is to retire on Mars, and working here makes that possible." And I think that's why they hired me. So for the last 5 years, it took almost 30 years, but this osmosis finally worked. And I got to work on the Artemis moon rocket, and it was a fabulous ride. I just retired on March 1st. But I'm waiting for my trip to Mars so I can officially retire. So with that, I'm going to go into, I've been doing ballooning for 37 years now. And I actually was involved in the first flight of EOS And the very first flight was Western Vision Network. Dave Klingerman, W6OAL, Mike Manis, um, and a few others. I sent them a little 10-meter beacon for their first flight, and they had a TV transmitter on it. Well, the beacon was transmitting. I was receiving it in New Hampshire at 73 Magazine headquarters, where I was working as their editor. And they were running around saying, well, I don't hear anything from the balloon. I says, it's still alive. I hear it here in New Hampshire. It's in eastern Colorado in a ditch, and I can hear it 1,500 miles away. And so I encouraged them that it was still alive, so they did a grid search, and lo and behold, after running into a ditch, they finally found it. And that was the very first EOSS mission, well, pre-EOSS. So it's been a good ride. I've launched about 700 balloons since, ranging from a half ounce to 400-pound rockets. So with that, let me get into my latest venture into Pico balloons, which is a little different from latex balloons, because a latex balloon, you've got this very expensive $100 balloon, and it's going to cost you about $100 to inflate it. So you've got about $200 into an expandable balloon. You go up into the stratosphere and you parachute back down a couple hours later and hopefully recover it immediately. And it's not in a swamp, alligators, cornfield. And by the way, during one of the EOS GPSLs, I always land in cornfields. Never fails. I'm either way up in a tree or in a cornfield. And I was so thrilled to come to Colorado for the first time to launch a balloon, because I knew it would not, there's no possibility of a cornfield in eastern Colorado. Well, the EOSS chase team came back with my payload, and it had an ear of corn and a stalk in it, and it landed in a cornfield, the only cornfield for miles around. And how many of you remember when we one of the payloads landed in a buffalo ranch? And the guy said, don't go in there, wait a minute. And he came back with this big bucket of Coke can size pellets. It was basically buffalo treats. And he said, a buffalo will stampede if you get them riled up, and they'll run over you and 10 fences of my neighbors before they even think about slowing down. The fences are only advisories to them. They won't contain them, but they will definitely trample you first. Because the way to a buffalo's heart is through these buffalo treats. And he started tossing them out to the buffaloes, and they started chomping on them, and we were able to go in and get the payload. So, and remember that tomorrow when we're out there, don't go into the buffalo ranch. So a little different way of ballooning. How many of you done Pico balloons? Okay. So for those of you who have never done it, instead of the big balloon that costs money, the balloon itself for a Pico balloon is basically a $20 party balloon. It's 32 inches. They have a spherical one, they have pancake ones, and cylinder ones. And we'll go over that in a minute. And the cost is not in the balloon, it's in the payload. And the payload you're not going to get back. This is an example of the one I designed called the Sky Tracker, and I'll show it online. But it's basically a little GPS. I have a chip antenna for the GPS at the top. Atmel 328P microcontroller, which I program with the Arduino IDE development system. And but I program it through a little pogo plug. There's no header. There's just 6 pads. I have a spring-loaded pogo plug, and it saves on the weight of having a header on it. Because when you're doing Pico balloon payloads, you want to keep it under a half an ounce. So we're trying to keep it under about 15 grams. So no batteries. although some people have tried flying batteries, but they tend to freeze out pretty quickly in the evening. We use super caps on the back instead. There's two super caps on the back. That's 1 farad, two 1 farad super caps. They're only 3-volt rated, so I had to put them in series. So I have a 1/2 farad there on the back, and that weighs less than a gram for those two super caps. Then I have a little clock synthesizer and a reference oscillator. I actually use a digital analog converter to create the APRS tones that modulates the reference oscillator. It's direct FM, and that gives me my required modulation on 2-meter FM. I also have a whisper version. It's the same board, different reference oscillator. And this board weighs in with the panels and the guitar string. This is guitar string. It's number 13 Ernie Ball guitar string. And they work out pretty well. I have to uncoil them, of course, 19.5 inches up and down. Those are power film solar panels. Now, they're not as efficient as monocrystalline cells, but I launch these from schools a lot, and the kids like to do that. And if you did that to a monocrystalline cell without a backing, it would just break right in half. And usually I let the kids launch them, and they always bang into the ground first. So they're pretty rugged. And they produce a nice voltage. These are rated at, I can get about 4.5 volts at 30 milliamps, constant current drain on that. So they work well with my design. So that's the Sky Tracker. I have a whole bunch of other ones I'll show you here in a second on the slides. So it's very easy to launch. One person could do it. And the only drawback is you want to make sure you have a light wind day and not a lot of cloud cover. And make sure there aren't any storms in the area, because they can be knocked down on the way up. I'm going to go through some of the whisper payloads that are out there. This is the Traquito, and what he does is, and you don't buy it from him, he basically gives you all the files, and you send it to JLC PCB in China, and they produce the board. They buy the parts, they assemble it, they make the blank PC board, and you get an assembled board back for pretty cheap. They're about $15 a piece. And for doing any kind of assembly, I have been using a place in Aurora, Colorado to do assembly. When I wanted to assemble the boards, it took me a long time to find a place in the U.S. that was fairly reasonable. There are all kinds of ones in Huntsville, but they wanted $80 a board to populate my Sky Tracker. I said, it doesn't have to be space qualified or mil spec. I just want a board that's soldered, and they wouldn't come off the price. I finally found a place in Aurora. They quoted me $60 a board, and I finally talked them down to $20 a board. But I had to order like 100 at a time. Now, JLC PCB, they'll do it for $6 a board in China. So I don't know how you compete with that. And it's beautiful quality. Now, he uses the Raspberry Pi Pico, and he solders the pads directly to his interface board. And the interface board has an SI 5351A, which is what a lot of people use for the whisper transmitter. It's fractional frequency. You can, it's very easy to set it up for whisper. But the one drawback is it does draw 70 milliamps when the GPS is on, because I don't think he turns the GPS off during transmit. The transmit current drain is somewhere between 35 and 40 milliamps when it's transmitting. But it works well. It uses the ATGM 336H GPS. which is a lower cost version of that competes with the U-Block's Max 8. But the Max 8's getting hard to find, and they're well over $15 a piece. And these are at around $3 or $4 a piece. So a lot of people are going to this particular GPS. No, you set it up through commands. You have to. There's 4 commands you send it to set it up for high altitude, and you have to do the same thing for the U-Blocks. You have to send it a command for airborne mode. Otherwise, it'll flatline about 40,000 feet. He's got a neat feature. You actually program it through a web serial interface. You just have you hook your serial cable to your computer, hook it up to the Raspberry Pi Pico Traquito, and program it, download his file. The only drawback is it's not open source, so you can't fork off of it and do modifications. But you can enter your call sign and the band and everything you want in it. He's using the QRP Labs telemetry method, and so he's got a way you enter the channel number for QRP Labs in his config software. But it's all done online. There's nothing to download onto your computer. It's all done through web-based. Now this is the QRP. Now I'm going to pass around a Traquito. This is an assembled Traquito. This is the QRP Labs U4B. Very lightweight. Now keep in mind though, they're very lightweight to begin with, but you have to now add the solar panels, super caps, antennas, and you're still going to be up around somewhere around 8 grams to 15 grams or so. And this is programmable. You use like PuTTY, which is a simple serial program. A real term will also work, but I found PuTTY works good. It's PUTTY. That's a free download, and he's got a little basic program embedded in it. And you program it in BASIC. How many of you program in BASIC, know how to program in BASIC? Well, there you go. Exactly. He's bringing back BASIC. So I used to program with the BASIC stamp that Parallax had, and so, but he can do some really neat things. You can do different modes, like a little Morse code message after it sends whisper, and he's got something called a glyph, where you can actually, in the waterfall display, if you're running an SDR or ADO, you see a little balloon symbol in the waterfall because he varies the frequency enough to make a little symbol, and it's got a little text of the mission number. So there's a lot of neat things you can do with this, and it's pretty inexpensive. I think it's $59. I'll pass this around. This one does not have geofencing, but I know somebody just recently posted a way to add geofencing to this in the basic code. The simplest, there's 2 methods of geofencing that I've seen. Mike Ajnowski here has come up with, along with W7QO, came up with a really sweet integer-based version of point and poly. And basically you draw a polygon around your country that you don't want to transmit over. And yes. He did that for cost. The original ones had a really tiny one. He breaks that off. You break that off before flight, so you save a lot on weight. But he did it for cost. He had a bunch of those laying around, apparently. So I actually preferred the smaller USB connector he used to have. He used to have just a standard little mini. So the geofencing in the point and poly works well because you just draw a line around, and if you're within that box, that polygon, it'll give you 01. If you're within it, then you just don't transmit. And it also is useful when you're flying APRS payloads in different countries, because there are 10 different APRS frequencies, national frequencies, in countries around the world, particularly in the southern hemisphere. Russia is 144.800. America are 144.39. So you have to draw boxes around everything and say, am I within that box? Then switch to this frequency. And my Sky Tracker will switch to different national APRS frequencies. In fact, China, Korea, and Japan have 3 different frequencies, but they're only 20 kilohertz apart. I don't know why they didn't agree. So I have to do that on everything, and I don't transmit over 3 countries right now. There are others that might be a little iffy in the future, but right now I don't transmit over North Korea, Yemen, and can anybody guess the 3rd country? Great Britain, the United Kingdom. Oh, that would be good. You, as a ham radio operator in Great Britain, you cannot fly amateur radio airborne in a kite or a drone or a hot air balloon or an airplane or a high altitude balloon. It's a holdover regulation from probably World War II, but it's been around for years. And so out of courtesy, I always stop transmitting when I go over Great Britain, because the UK hams, when they do their have flights, they have to go to license-free transmitters like LoRa or anything on 434 UHF frequencies and low power. That's what they have to do. Now, hopefully that rigs will change, because they have a big high-altitude ballooning organization, very active in Great Britain. So the other way of doing geofencing is to just take the 4-digit grid squares that mask over that particular country and say, am I within one of those 4-digit grids? And don't transmit when it's a little blocky, but it works. And in fact, that was the one that they recommend. The guy posted, a fellow in Great Britain came up with that idea. This is my Sky Tracker I just showed you. Basically, you have to make it as light as humanly possible when you're flying a Pico balloon payload, and then make it even lighter. You have to do that. Make it, the PC board on my Sky Tracker and Zactec here is 1/3 the normal thickness of a PC board. I have to special order that at JLC PCB. I can't even get them that thin in America. I can get a half thick board for $37 a board for the blank PCB, and JLC costs $3 a board for the thin boards. Well, Osh Park gets them from China. Exactly. So this is I wanted to mention also that the students I've worked with at University Alabama Huntsville, they have a space hardware club. They have over 100 members, and they have a balloon sat team, they have a robotics team, and a rocketry team. And they do a lot of outreach flights all over the region to high schools and middle schools, doing balloon launches every season. And some of the students came up with a great idea, because one of the students is big and he's a meteorological student. He wanted really high resolution pressure, temperature, humidity from Pico balloons. And so he came up with this. It's the PTH board. It weighs about 0.8 grams. It's got a pressure sensor, humidity sensor, and a thermistor on it. And I've been prototyping that onto my next version of my Whisper board. And I've actually flown it once just before coming here about 3 months ago. It sat, the balloon failed, and it sat in the treetops of Georgia for 3 months transmitting every day on 10-meter whisper. So I was monitoring the atmospheric conditions in Dublin, Georgia, remotely, and it was being received in all over Europe and all over the United States on 10-meter whisper. So this is called the PTH board. I believe they'll be offering this for sale. I'll probably handle the sales for them, but I'll pass this around. Just be a little careful not to touch the thermistor itself. But we'll probably try to make this available to people. It is available through, all you do is supply power and an I2C interface. And there's a couple of Arduino routines that they will supply with it to show you how to interface with the sensors on it. I got very high resolution data off of that. And they have flight tested this against an actual RS-41 radiosonde, and all the way up to 100,000 feet, it compares very well. That particular pressure sensor works well up to 10 millibars and beyond. A little difficult to interface, but it's like a 24-bit A to D in it. This is my new version of the Whisper board, SkyTracker, showing how I attached the PTH board to it. And that's the flight that I sent to the treetops of Georgia. And this is my newest Whisper board, Whisper 2, SkyTracker 2. It's got, it doesn't usually have the SMA connector. I do that for testing. And this is a little serial interface so I can do my debugging. So I left it on there, but this will, and I'm using that new ATGM 336H GPS. I'll pass that around. That's the SkyTracker 2. I should have those available in the fall. Zactec. This is an older Zactec, and it's a similar circuit. He's got the super caps, microcontroller, and the SI 5351A. Most everybody uses that sort of combination. It's just a little bit different configurations in the power distribution and the solar panel attachments. And Harry in Scandinavia sells this. He uses the power film solar panels, and he has a very unique way of attaching them. I've been doing them horizontal, but he does it kind of at a 45-degree angle to get a little, try and get a little lower sun angle. But he draws, I don't think he turns his GPS off during transmit. So he does draw about 70 milliamps on transmit. He's got a different altitude scheme than what the QRP Labs uses, and this is very similar to what my scheme is and Mike Hodjanowski's scheme. We basically use the Whisper only produces those levels of dBm, 0.37 up to 60, so it's not a continuous dBm power field. So there's only 18 to work with. So we take the power levels, and Zactec basically divides it by a certain number to get the altitude. Ours, I would go 1,000, 2,000, 3,000, 4,000 meters in the same chart. But that's how we get the course altitude in the single frame of a Whisper frame. Then I do a second telemetry frame, which has fine altitude in 60-meter increments using that same kind of chart, and then I add the two together. So I can get within a plus or minus 60-meter resolution with two Whisper transmissions. Now, a lot of people have asked about solar testing using grow lights. Is it possible? So I decided to order, or this, by the way, is before I get to that, this is the Adafruit SI5351 board. You can roll your own Whisper transmitter with a Arduino Mini and one of these boards, and a GPS module. And in fact, K9YO, if you go to his website, search for K9YO tracker, he shows you how to make your own, roll your own breadboard using those components, and this is one of them. The only drawback is this does not use a temperature controlled reference. It uses just a crystal. It drifts like crazy. But if you put some padding insulation on it, it should help keep it within the necessary requirements. In fact, one of his payloads was the one that, well, we think it is, was the one that almost caused World War III, and we'll get into that this afternoon. Actually, I have it at the end of the talk here. So I tried solar testing because, you know, in Alabama, I want to test things out in the sunlight, and it's hard to find, even in the sunny South. We get storms, cloud cover. When I used to live in the Midwest in the winter, we had to shoot flaming arrows at the clouds to see if we could relight the sun. So, you know, we really want something controlled, test our payloads, as solar power is the way to go for these small payloads. So I researched a number of grow lights, and these only draw 600 watts, 1,000 watts, and actually, I'm sorry, 60 watts for the top one and 100 watts for the bottom one. And they really do quite well. They're pretty full spectrum. The only thing is the one at the top was cheaper, and the dimming mechanism flickered the lights on and off. And I noticed when I held up my sky tracker to it, I was getting this weird modulation because I didn't have the super caps on it. With the super caps, it was fine, but without it, it was turning it on off rapidly. It was actually modulating it. And I figured it out. It was the dimming mechanism. Now, the Mars Hydro one down below uses a different dimming mechanism, and it works great. So this is the Mars Hydro. It's the TS1000. It's a 100-watt unit, and if you space it about 7 inches in front of it, you pretty much get full sunlight and full spectrum. And I can simulate an outdoor test any time of the year or day. And this works quite well for testing. And they're pretty reasonable. I got it on Amazon. So it's the Mars Hydro TS1000. It's got a really nice dimming mechanism. So you can actually crank it down. I have a lux meter, and I can find the point where if I pulled the light sensor right where the solar panels are, I can find the point where it's going to die, and that'll give you a very good idea of what solar elevation you'll be able to get down to during an actual flight, which is very important. I can get down to about between 12 and 15 degrees minimum solar angle with flat panels. Some people have angled the panels during the winter and used a magnet, super magnets, and a swivel, and actually got it to always point south. So that's another thing you can do as well. But just a flat panel, you can probably get down a little bit below 15 degrees minimum solar elevation. So about an hour above sunrise, after sunrise, or an hour before sunset is your operational range. Now, some people have made pyramids with additional solar panels, and they get right down to sunset. Now let's talk about the balloons. Is there any way to dim the lights a little bit? It might have a little front light. Yeah, that might be a little better, see? Is that too dark for everybody? Okay. The balloons that are most popular are the Yokohama, so called because it's Yokohama Balloon Company in Japan. You have to order 10 at a time, and the shipping charges is about $100. So I usually get about 50. But they are about $18 a piece plus the shipping. And what we've been doing lately is the students at UAH have been inflating them, and they'll pressure test them, and then I'll sell it for them for about $50. They're $30 without testing in small quantities, so you don't have to buy 10 at a time if you want to test them yourself. And they're $50 if they're pressure tested. And it helps out the Space Hardware Club. The clear orbs looks almost exactly like the Yokohama. In fact, I suspect it pretty much is from the same company. You can buy those from Balloons Online, balloons-online.com, I think it is. And it comes from Canada, so you don't have that big shipping charge from Japan. But in the flight test I've done, comparing the Orbs balloon with the Yokohama, the Orbs tended to be about 1,000 feet lower float altitude. So I've got to do a couple more flight tests to see if that is really true or not. But it looks identical. And then SAG, they have a silver coated one that people have been using. The only drawback with that is you do tend to be a radar target at that point, and you might be at risk at some fighter jets. So, but they've had good success with the SAG balloons as well. And then Scientific Balloon Solutions, that's K6 RPT, Ron Meadows in San Jose. They make the SBS 13s. And I would, the best results I've had with those are I pressure test them, but don't pressure test them to the level that you would with a Yokohama. Probably around 0.2 PSI max on one of those. The reason you have to, oh, let me go back here. I skipped over a slide. The reason you have to go, yeah, there we go. The reason you have to pressure test these spherical balloons is that they come flat and they're kind of adhered on the seams to each other. They kind of stick. So they claim you have to be at 70% humidity in the room. I basically turn on the shower as hot as it gets, take it into the bathroom, or I have a number of humidifiers in the bedroom, and you got to get up to about 70% so that the seams don't tear when they separate as you inflate them. And that's why you can't launch them just right out of the box, because at the cold temperatures, they're just going to tear and pop. So you really have to pre-inflate them. I ramp them up to about 0.35 PSI and sometimes up to 0.4. And I use this manometer. These are pretty cheap. I get these. That's Rise Pro. Works great. It's a little digital manometer. I get it from Amazon. And that testing setup on the left, you'll see I've got an aquarium pump and the Rise Pro, and I inflate that balloon up to 0.35. After I've got it stretched, and it makes horrible sounds. It sounds like it's about to blow up as the seams separate. But it is easier with the humidifier. Now, you have this tire inflator from Craftsman. It's a $70 from Lowe's Craftsman tire inflator that has a vacuum port. It's digital. And I do the last bit of testing because it's hard to get it with the aquarium pump. That's a 60-gallon aquarium pump. It's hard to get it up to 0.35. I get about 0.2 with an aquarium pump. So I top it off with my tire inflator. You see part of it on the left there. And somehow my slide of the tire inflator got lost or shifted. But anyways, run it up to 0.35, and then you vacuum it out with the vacuum port on the tire inflator. And it takes about 30 minutes to vacuum the air out. It takes about 2 hours with the aquarium to get it up to volume. And that's my humidifier that I use. You see it's at 76%. We actually did, the students did a chart based on empirical testing. They actually took a few of these up to burst pressure in the lab. And there's the sweet spot that you want to hit. You want to be between 0.2 and 0.5 internal PSI pressure for a super pressure Pico balloon. If you exceed that, in the top range, you're in the risky range. You might get a little longer flight out of it if it survives, but that is risky. And it hit the red range, it's likely to pop. And conversely, if you're below this range, you're not going to have enough super pressure at night to stay aloft, because you have to maintain that volume at night. And you'll lose that solar heating and down it comes. Oh, yeah, there, I've showed the Craftsman. That's a really handy unit. You can see this way. It puts out too much pressure for the inflation, so I Y the connector and I bleed it off to keep it down to about 0.2 psi as it's inflating. You can just use that Craftsman to inflate these instead of the aquarium pump. But I think the aquarium pump gives a little more gentle ride. And then on the right side, you see the vacuum pump deflating the balloon afterwards. Now, Balloon Time used to sell, still sells, that kind of tank, a little portable tank, looks like a propane tank. You'll see it in Walmart and Dollar General. They're almost $50 a piece. They used to be $30 a piece. And what they've done is to make it more environmentally friendly, as they quote say, and they've added air. It's 80% helium. And I actually suspect it's a little less than that. We just had a flight use that Balloon Time stuff from Walmart. And instead of floating at 38 to 40,000 feet, they floated at 25,000 feet. And they didn't stay up long. So I found on Amazon a company that claimed to be pure helium. Well, it's probably 98% or 99%, called Party Factory. It looks just like the Balloon Time canisters, but it says it's bottled in Germany. And we tested it on 2 flights recently, and it works great. It really is good helium. And it's $60. $10 more than the Walmart stuff, but this will get you there. And it's very lightweight. It's got 14 cubic foot in it, and that's enough for at least 3 Pico balloons, maybe 4. So if you want a good source of helium, now if you're doing a lot of Pico balloons, get yourself a $20 aluminum cylinder, a 20 cubic foot cylinder. They're about $100. And go to a mom and pop welding shop and they'll fill it up for about $38. Okay, gram scales are nice to have. That's a $10 gram scale. It goes up to 220 grams. And that's how you measure the lift. And what you do is this is a 50 gram hook weight. Put it on there, tear the weight so it says 0, and what it's lifting is a negative number, and that's the amount of lift on the neck of the balloon. I'll pass the hook weight around. I get these for $4 from a scientific supply educational company, and these I get from Amazon. But always handy to have if you got to keep it as accurate as you can. You want to be within a gram of your final lift to achieve the amount of free lift, which is typically for a Yokohama balloon and a 12 gram payload is somewhere around six to 7 grams of free lift. That's above the lift of the weight of the payload. Payload plus free lift is your total lift that the neck of the balloon should lift. So instead of pounds that you're used to in latex balloons, we're now talking grams. And these are a couple items that are handy to have. If you're using that Balloon Time or that Party Factory tank, I found these really cool 3D printed adapters that will go over that rubber nozzle of the helium tank and reduce it down to a small hose. And in fact, here's the my filling hose. I use these polystyrene tubes. They're very smooth. They won't stick inside the neck of the balloon and mess up the valve. They have a little internal valve. And these are from Evergreen. I use the 225 or the 226. I have a typo there. And that's about it's 3/16 is the max you want to use. You don't want to put anything bigger than that in it or it'll tear up the filling port. I'll pass this around. Now, a hole punch. Those are handy to have. I use a little eighth-inch hole punch. Punch a little hole at the bottom of the fill port to hook the hook weight in to measure the lift. Yes. Okay, is that good? All right. All right, we'll see if we can play this video. Do we have sound with it? The video's not playing. It has to be in presentation mode. We did a launch at the Dayton Hamvention of 2 Pico balloons, and 13-year-old girl on the right, college student on the left, and we did it from the food court. And W8BI11 is on the left, W8BI-12 is on the right. W8BI11 was never heard again after it crossed over the Gaza Strip. So, be that as it may, I kind of suspect what happened to it because it was flying great until that point. W8BI, however, 12, went around the world once in 2 weeks' time and went around for another almost lap, and 350 miles from completing its second lap around the world after being a month in the air, it hit a severe thunderstorm over Iowa and landed just south of Pella. And Mike and Jim went out and searched about a 20-mile area for it. I'm hoping a farmer will find it because I do have a backup recovery system, which is my email address. And that would be quite a feat, though. That would be the first time that we've recovered a Pico balloon that has been around the world. Mike, you almost did it. You came within a mile of it, but couldn't find it. Because Mike landed one in New Hampshire after going around the world, and
9, 8, 7, 6, 5, 4, 3, 2, 1, liftoff. There they go.
They are transmitting nice and
Yeah. One's got 6.5 and one's got 7.2. They don't ram into each other.
which?
all right, thanks. That was the free lift. Yeah. And one was the Orbs and one was the Yokohama. The Orbs is the one that got shot, well, possibly got shot down over Gaza Strip. And it got GPS spoofed. They both did. As they got close to Israel, they all of a sudden showed up in Beirut airport. And one of them showed up in Ankara, Turkey, at their airport. And then the next day it showed up back in altitude. So a lot of you have probably experienced some GPS spoofing as you get into the Middle East. And the only reason I can think of why they chose Beirut airport is if the Hamas sent up a missile that's GPS guided, they wanted them to hit Beirut instead of Israel. Oh, really? I didn't. I can't get it to advance. It's not advancing. Oh, there we go. Sorry about that. All right, got a couple more slides. This is, I'm going to fly this tomorrow on the Pella Group's balloon. And this will be a WB8ELK-11. It's using my Sky Tracker as a latex tracker. All you do is take the solar panels off and put a battery pack on it. And it's 20 milliwatt APS tracker. And you would be amazed, I've compared this to a half watt or a 1 watt APS primary tracker, and it doesn't miss a beat. You don't really need a lot of power on APRS to be received. So just the nature of APRS with its short burst. So it actually, a lot of people have used these as primary trackers. And it's controlling an Iridium modem. How many of you have ever flown anything or fooled with Iridium? This is called the Rock Block. It's available from Adafruit and SparkFun, and they're about $300. They have a built-in patch antenna, but I prefer to use the $60 helical antenna that screws onto it because you get a little bit better signal to the satellites. It's a two-way unit. I can send down data and send an email to it. I actually send an email to release a glider in the stratosphere. So I sent an email, and 8 seconds later, a servo, it picked up the message in this modem in my balloon, activated a servo, and dropped the glider, all by an email command. I'll pass this around. I'm going to fly this tomorrow, and it's just controlled from the serial, my secondary serial port on the Sky Tracker. And I also have a interesting power supply using these 18650 batteries. Somebody asked about, remember the lithium sulfur D cells that we used to get in the military packs? Well, these are the next best thing. They're rechargeable. They actually use these in a lot of our small sats that piggybacked on the first Artemis moon mission that we flew. And this is the holder for them. I'll pass these around. It outputs 5 volts and 3.3. They have multiple jacks at an amp, 1 to 2 amps output. So we'll see how that works tomorrow on Mike's mission, Mike and Jim's mission here. And there's the battery pack. It's $13 from Amazon. And it uses the two, you have to put 2 of those batteries. So that I forget how much those cost, maybe a couple bucks a piece. The 18650, not as bad as some of the smaller ones, but yeah, they're. Well, we'll find out. Yeah, we have it insulated, but we'll add some to it. Yes. Oh, yeah, I typically run the Everready L91s, the AAAs and the AA lithium primary cells. But I needed to put a regulator because the rock block doesn't have a built-in regulator. You have to do a very high power because it can draw up to a half an amp. So I couldn't find in time a 5-volt regulator, or I would have used my lithium pack for the AA cells with a 5-volt regulator. That's the one drawback with the Rockback. I rolled my own Iridium modem years ago that had the regulator on it and the microcontroller on it, and I may do that. If I get time, I'm going to build another one. At the Iridium, this is what comes down through email to you. It'll also send to a website if you have a web server set up. And it's a little expensive. It's $13 a month, and there's about 10 cents to 12 cents for every data transmission. But it also gives you a Doppler shift estimate of your position based on the Doppler shift of the Iridium satellites. Talk a little bit about WSPR, how the over-the-horizon telemetry works. When we did Antarctic missions, they were received on the opposite side of the world from Antarctica using 10 to 20 milliwatts output. So 10 meters in particular has been working very well. It's been open just about every day. This is the data you get from WhisperNet. We scrape it with a Python script, convert it to APRS format, and send it to SonHub, and APRS FI. And it shows up as an APRS balloon on the track balloon tracking maps, all from a WSPR. So the WSPR data is scraped by the Python script, both transmissions decoded and sent out as APRS. And it works very well. All you do is run a little Python script on your home computer, and it goes and I have a little Python anywhere. Anybody cool with that? It's an online service that you can write and test Python scripts and set up your own little web server. It's pretty cool. It's pythonanywhere.com. Now, one risk with Pico balloons. How do you avoid the F-22s? We are actually trying to educate the government, and there was a recent article which I will mention. I'll show the article in the panel discussion this afternoon that the NORAD is actually using SonHub to track our balloons to determine if it's a foreign balloon or something that needs to be shot down, or a ham radio amateur Pico balloon. So we've finally gotten through to them that there are ways of finding us and identifying us. It's not really fun to spend $500,000 to shoot down a $100 Pico balloon, which is what they did in the Yukon right after the China balloon. There are some new regulations in the works. The SOAR Act required an ADS-B transponder on all balloons going over 10,000 feet. I tried to contact Senator Kelly directly. He's an astronaut, big into STEM programs, telling him this would kill a lot of STEM programs. And he wouldn't listen to me because I wasn't his constituent. So I found NU-7B, a Pico ballooner, in his district in Arizona, and Steve Rector contacted them, got a discussion. We did a Zoom call with his aide that was working on this act, and we said, look, he's going to kill all kinds of programs. All we want to do is reword it to any form of transmission of altitude and position instead of requiring an ADS-B. and add a committee member, because they're going to form a committee to detail all the balloon changes. And they listened to us, and they changed the requirement from ADSB to any form, and they added us as a non-governmental and educational committee member. So we'll talk in detail about that this afternoon in the panel discussion. And this is a top secret slide I got, I'll probably get in trouble for showing this, but they were so embarrassed of spending $500,000 to shoot down a Pico balloon that they came up with this more cost-effective method. With that, any questions?